Hi, this is Sonal Bharti, and we are here at KubeCon in San Diego, and today we have with us Idit Levine. You are founder of Solo.
Yeah.
First of all, welcome to the show.
Thank you so much.
Of course, I have been monitoring your work for a very long time, so thanks for sitting down with me, and because you have created a lot of companies, So I'm curious about Solo. Mm-hmm. When and why you created the company, what problem you saw in the market or space that you wanted to solve?
Thanks so much for having me, first of all. So when I started Solo, before I started Solo, I actually worked in a lot of organizations that always was kind of like in the edge of the technology. So I started with a startup company like Dynamic Co-op, who got acquired by VMware. What we realized is today is something that we started. And then I moved to another startup company. And what I realized that there is a huge gap in the market between what we actually, the innovator guys, putting out there for the open source to where actually the customer are. So the first kind of like principle for Solo is, customer first. So that's where it started. But when we try to figure out where the customer is in the journey and how we can help them, what we realize is that every customer that we talk to starting with the same problem, which is we want to move from monolithic to microservices. And what I will say is that, look, we try to move from monolithic to microservices, and the hard part of actually doing it, or so they think, is actually rewriting the application. But actually, to me, the big problem, and this is what we see happening, is not the rewriting of the application to microservices. It's actually the fact that now, if you have a microservice application, that means that you actually have distributed application. And if you have a distributed application, that means that everything is happening on the wire, which means that now simple stuff that you could have done before, like just route between, like in your application as a binary, you didn't need to route. But now simple stuff like make two microservices talk to each other, make them talk in a very secure way, as well as the observability of what's going on in your cluster, is three things that it's pretty complex to do. So that's kind of like the first phase of how we're helping them. And all of these three things is actually helping by Service Mesh. So we knew from the beginning that we wanted to actually start helping company by adopting Service Mesh. So that was kind of like the first thing that we started. But we also realized that it will take a long time to actually, until Service Mesh actually will become a thing. So we tried to figure out what will be the first thing that we can actually do for our customers to not going to be a full Service Mesh, but at least will help them and going to be kind of like a stepping stone to adopt Service Mesh. So what we did first is basically we took Envoy, which is Envoy proxy from Lyft, that it's basically it's a CNCF project as well. And it's basically the building block for every Service Mesh almost that exists today. And what we say, we're going to build a very good API gateway on top of it. So that's where we started. We basically built a product called Glue. To me, is the best. It is the best API gateway that exists in the market. And the reason is because it's actually built with all the new technology, distributed application, storing the storage is that we're using a CRD, which means in Kubernetes, which means that you don't need another storage. So it's a really, really strong API based on top of a Envoy proxy, and just like its name, Glue is its name, and like its name is basically also gluing those environments, because we understood that every given customer most likely will have also static application as well as serverless. So basically it's gluing those environments and managing it all, for security and so on. So that's where we started. But as I said, we also always wanted to get to Service Mesh. So what we did after it, we realized, okay, so we have this API gateway. It's running in production in a lot of environment. It's really, really good. It's scale. We are contributing to Envoy. We understand the ecosystem very well. What about Service Mesh? What we realized is that we don't want to build a Service Mesh. And here's why. Because everybody will build a Service Mesh. And there's going to be a huge competition, and there is no good need for another player to compete. I think they had it. Like eventually there are going to be a lot of Service Meshes, and it's all good. So what I tried to figure it out is how can we help, given the fact that Service Mesh is going to be a thing, what will be the next problem that people will try to solve? What we came with is that they're going to be more than one, right? And the reason they're going to be more than one is that you will have more than one cluster. And if you have more than one cluster, you will need more than one mesh. And also, if you look into the ecosystem, you will see that there is also the three big cloud actually running different Service Mesh. So if it's the guys from AWS who's running App Mesh, if it's the guy from Google who's running STO, and Microsoft. We'll see what will happen with them. So in the nutshell, eventually you potentially run more than one instance for sure. And the question is maybe even more than one mesh. So what we basically came with is this abstraction layer that, first of all, let's make all of them speaking the same language. We open source a project called Superglue that's doing it, but then Microsoft and us join together power and basically announce it as a new project called Service Mesh Interface in the last KubeCon. And basically what it is basically an interface that agree on every, basically the API for every service mesh. So we built that. And then the other thing that we also did, we basically realized that we can actually group meshes together. Because in the nutshell, you will have app mesh, you will have maybe Linkerd on-prem. You most likely want to treat both of them as your production cluster mesh. And if they're your production mesh, you most likely want to give them the same configuration. So what we're basically doing, we're grouping them as one big mesh, and we're basically flattening the networking and letting you treat like one big mesh. So the last thing that we understood is that, okay, so we basically have and we announced this project called Service Mesh Hub, and Service Mesh Hub is basically doing all the stuff that we actually discussed. But what I also realized is that Service Mesh is basically a platform. And we basically abstract all the network. We abstract the network north-south, right, with API gateway like Glue. And we abstract the network east-west with Service Mesh. In the nutshell, eventually, if you abstract all the network, it's giving you a lot of power, right? You can actually give a configuration file and change all the configuration, all the way the network is working. But it's also very dangerous, right? Because if you think about it, with your power, with the big power, great power, bringing great responsibility, right? So you need to make sure that you're making your mesh resilient. So we actually announced yesterday a project called Autopilot, an open source project, that basically will help you to make your mesh resilient by making the mesh adaptive. So it's adaptive mesh. What does it mean? It can fill the environment, and based on this, it's going to change automatically the configuration of the mesh. And it's an open source project, and what we did, we basically built an operator frameworks that will give you the ability to build operator to specifically very opinionated to service mesh, and that it will be able to make it very adaptive. So we're helping them migrate with great API gateway, stepping stone to service mesh, then we help them adopt service mesh and manage that and orchestrate that, and then we actually help them make it even adaptive.
How would you define service mesh?
When you are actually building an application, usually what people was doing so far, they were putting the actually operator code inside your application embedded. So you will import a library in order to do logging. You import a library in order to do routing. So that's great, but that's not healthy, right? The concept is not healthy that you actually embedded logic of the business logic application with the operation, because that means that if your provider upgrades his library, you need to roll a new version. So what Service Mesh is giving us, and this is really, really powerful, it's basically giving you the ability to take the operation log and basically bring it to the sidecar proxy. And because the sidecar proxy, it's all configuration, so now you can actually very seamlessly control and abstract the network and say, these microservices can talk to this one, that cannot talk to this one. Here's the log, let's force put it in a open tracing or something like that. So it's giving you the ability to basically abstract the network, and you will be able to handle the network very easily with configuration files. So it's a lot of, flexibility.
Awesome. Today is, I think, third day of KubeCon, right?
Yes.
I'm pretty sure that you have been to keynotes, session.
Yeah.
What has been your observation so far in this KubeCon? Because you have been attending for a very long time.
They said that before, but Kubernetes in a way become a little bit boring, right? I mean, there's not a lot of innovation happening there. But what does happening there, which I think is really interesting, so what we see is service meshes definitely have a hype, right? Everybody's talking about it, everybody want to learn about it, this is kind of like the new thing. And the other thing that is very interesting is Webassembly. So Webassembly basically is technology that started in the browser, and that was the ability to actually extend the browser in a secure way, that if you're writing a code, it's not going and something wrong with it, it's not going to take down your browser. And basically, a lot of projects in the Kubernetes ecosystem actually decided to adopt it as a way to actually extend the functionality. So Envoy is one of those that we're pushing it back really strongly together with Google to basically be able to let the customer write easily code in any language and basically extend Envoy that in the request path this code is going to be executed, but in a way that you don't need to recompile Envoy, which is pretty complex. Project like OPA also announced support for WebAssembly. We announced support for WebAssembly, so actually Glue is the only API / Envoy thing that's supporting WebAssembly today. But STO is going to add that support and so on. So in the nutshell, eventually that will be a very interesting way that will give a lot of power to the user to actually kind of like unify it or make it specifically for him. So I think that will be big and it will change a lot in the ecosystem.
Right. When you look at a lot of open source projects, especially in the CNCF, because it has kind of become a very welcoming community, so everybody is kind of contributing to their project. So there are always projects which are like either overlapping functionality or at the same time there are glaring gaps between the functionality. So in the context of service mesh, what is the situation there?
So not much. I mean, in service mesh there is, so that's actually funny. So Envoy is the proxy that everybody is using, and most of the service mesh is using it today. There's Linkerd, which is a service mesh company, as a project that is in the CNCF, actually not using Envoy, which is interesting. But actually, Google just announced like a few months ago that they're not going to add STO to the CNCF, and there was a lot of Knative, by the way. There was a lot of pushback for the community about, that's not open enough and what's going on. It's not government. So that's actually, so if you're looking at the service mesh ecosystem, actually the only one that actually there is Linkerd as well as Envoy, and STO is not going to be there. So it will be interesting to see what else is going to come there.
So we are at the end of 2019 and we are soon be walking into 2020. But if you look at the service mesh space or cloud native space in general, not service mesh, what are the trends you think will be there in 2020? Or from the community's perspective, a lot of, as you said, Kubernetes has become boring. So for 2020, what does the plan look like?
So this is a good question. I think, to be fair, it's like this market is moving so fast.
There's
no way we will be able to predict that.
I'm not talking about December of 2020. Let's say January of 2020.
Yeah. I mean, I think that nothing will change dramatically. I mean, we know what is the trend. We know what people are going. It's interesting that serverless is not a trend anymore. That's kind of like, I think, the hype went down dramatically. As I said, I do think that the only thing that I see right now as a trend, and it will continue like this, is this service mesh and WebAssembly. Trying to figure out if there's anything else that I was impressed. There's not a lot of new projects that are getting out there. I mean, I will say that, maybe I think that one of the trends that I see that is going to come up right now is the fact that people will try to build on top of stuff. So like to make it more and more opinionated, but more and more user-friendly. So I think you will see a lot of those actually think about the user, think about the UX and the user experience. I think this is something that you will see trending because, we already kind of like set up this. The Docker, the container is already setting down. Then we went to the orchestration, it's setting down. Now we're trying to build in a side to make it even more solid. And now the next level will be something like Knative and the stuff that's coming on top of it, the operators, basically.
Awesome. Thank you, Idit, for talking to me today. And I look forward to talking to you
so
in
much.
some point in the future.
Really
Thank you.
Appreciate it. Thanks so much.